who are the regulars. We wish more people would join and take benefit of this. So, yeah, so let's dive right in. So, yesterday, among the people who have attended, you would have seen that we have started discussing about the um, machine learning models, specifically supervised learning models, and both Barney and Sharath at a high level tried to cover the entire gamut of what all the things we have, what are the various aspects that are there within the the supervised learning algorithms, various algorithms, including partly even time series models. We have spent some time. So what we'll do is we will discuss one small aspect which we kind of skipped for want of time, and which is uh, unfortunately not given a lot of importance even by many of the learners and some of the data scientists as well. So Sharath, I want you to take over the baton and discuss something about what you have faced with reference to reproducibility and what you have done to address it.
Good evening, everyone, and very happy to connect back. Happy to see the regulars. Thank you very much, Nathan, and let me jump into the answer. With respect to reproducibility, yesterday we were discussing briefly about this. I just wanted to focus more on this point because this is very important. Now, when we talk about data science or data science job, few years back, I would rather say, personally, I would say pre-COVID era and post-COVID era. Pre-COVID era, as a data scientist, you are expected to build machine learning models, do analytics, that is descriptive analytics, predictive analytics models, do the hyperparameter tuning and give the best model to the development. Okay, so that's the general flow. And in order to develop this, as a data scientist, we used to have the historical data and we split the data into train, test, or we also split this into three forms: train, validation, and test. And we try to run through different models regressively, iteratively. We would try to find out the best model by experimenting. Once the best model is ready, we try to give it to the end user in whatever the form. We'll get into that subject. I'll talk about that briefly. But once the solution, the final solution, is handed over to the customer, the expectation is that, this is important, the expectation is that the solution should work in future. That means when the new data comes in, the expectation is that the model has to work just like how it has probably worked on training instance, training data, and then testing instance, right? And that is your on test data. But the problem is we don't know what kind of new data might come in, right? So we have to try and ensure that the model is also verified for getting similar results, quote unquote. The conditions have to be similar. So we basically put all these details up front. But is the model working similar if I give some new data to the model? So to verify this, we basically split the data and then gather the stats of each and every data set that we have. Like training data set, we do EDA, we gather all the stats. We have validation data set, we gather all the EDA, the stats related to that. Then test data set. And we may also have new data as well for further round of review and taking the feedback from the model. So all these four data partitions or data sets that we have should have similar characteristics. This is the condition, quote unquote condition, that we'll have to look at. And if we pass this data to the model, then the model should perform very, very identical on these four different data types, data sets. This is something we will have to verify so that we can generalize and say that the model is going to work at a specific level of metrics or performance, you can say. Even if there is a new data that is coming in, again, quote unquote, the conditions have to be similar for the new data as well. which is very identical to the existing data sets that we have. Right? So we try to put those restrictions and then we generalize the model. So this is something that we check for reproducibility of the model's performance. Nitin.
Thank you. Thank you so much for the detailed answer. Barney, I have a slightly different take on this. So when I say different take, a different question altogether. So
Okay.
Bharat has explained the necessity of reproducibility to ensure that we are in line with the future data. All that is very much clear. So does it mean that the efforts that will go in for the future data points, what we engage the customer for ensuring you have these quarterly maintenance, half-yearly maintenance contracts where we'll update their system, that efforts will be reduced considerably because we have ensured reproducibility, or that effort still will be there? If that effort is still there, what is reproducibility doing? I'm just trying to understand that.
Sure, Nitin. Absolutely. So, there are two parts to your question. One is what with respect to the new data. With respect to the new data, as in how you get it, you will have to follow all the data pre-processing steps which you have applied while you were training the data. Before you supply data to your machine learning model, training data, you would have done certain data pre-processing techniques. The same techniques should be applied on the future data also before you supply them to your machine learning algorithm. That's one part of the question, Nitin, that you have asked. Another part is, can probably I give a different perspective with respect to reproducibility? Okay, reproducibility means when you tell to the customer that, dear customer, do you know what? I've got an accuracy of 92%. What if your customer asks you to show that result once again, that you're getting an accuracy of 92, 93, whatever you claim? And what if customer says that, good, that you have tried it on your environment, on your server. Would you like to try it on my server and then show me the results? If you did not document what is the version of Python that you were using, what were the versions of libraries that you were using, what kind of data set you were using, what were the data points within that data? If you don't have exactly the same setup, you might fail to reproduce the results on the client environment or the customer compute environment infrastructure. Also, you need to document the operating system, the version of that. What are the other softwares which are involved alongside building your model? You'll also have to document the details such as your compute. What is the processing speed, right? What was a processor? How much amount of RAM you had? All that is needed because if you want to replicate and reproduce the results on the client environment or client infrastructure, all these things should be recorded. And this is another aspect of reproducibility. When someone says, hey, show me the exact results, you claim that accuracy would be 92%, and you claim that the predictions will happen within 3 milliseconds. Show me, prove it. For that, your production environment, your hyperparameters, the algorithms that you were using, the dataset on which you have trained your model, all of those things you should have recorded, right? And another very important thing is building the model and giving it to the customer does not mean that you got high accuracy and you're able to give the prediction results faster. It also includes a lot of aspects such as model compression. What if the customer says that you will have to deploy the model on our CCTV, on the video IoT device? In that case, if you end up building some kind of a deep learning model, it would be very large in size. It could be probably 20 MB, 30 MB file. And if you want to deploy such 20, 30 MB file on your mobile application or some kind of IoT device or CCTV camera, etc., then it would not fit in. Even if it fits in, the performance would be very slow. To address that, people use model compression techniques. They compress the model significantly, make the size smaller, so as to deploy that on the mobile application or on some edge computing device such as IoT device, etc. All these things, when you do it as part of your model building, and when you're satisfied with the results, when you feel that, yep, we are good now, we have evaluated the model against the success criteria, business, economic, and machine learning, and we are good, then customer would certainly like you to replicate the results in their environment. For that purpose, we need to record all the details of the model and the data and compute, etc., so that you might reproduce the result. So that's why every experiment should be documented. And there are a lot of AutoML tools which are available, especially the commercial versions like SageMaker, Autopilot, etc., which would automatically record all of these things, so that you don't have an additional headache of remembering what versions, what operating system, what Python version, what libraries versions were used, etc. You need not worry about all of that. That is automatically taken care of. But it costs. One of our student on YouTube channel is asking this question on, we have AutoML models. Why do I need to do it manually? It's cost at the end of the day. Right? Automatically, you can do that, but it's going to cost you a lot. Would you be willing to spend that money? Is a question that you need to ask, right? But yep, AutoML tools are picking up fast in the market. Yep, thank you, Nitin, and sorry for a very lengthy explanation there.
Yeah, perfectly understandable. That is the price I have to pay for interviewing the experts. It is not an interview where I am trying to test your, trying to test what all you don't know. It is trying to figure out, that is what generally happens in an interview, right? When you go there. Another off-track tip that I'd like to give you. So when you go for an interview, participants, if you get stuck up with something that the interviewer knows you don't know, you can be sure that if he's a even slightly sadistic person, is going to go around and around and try to find out how much of it you don't know. All right. So here with Sharath and Barney, it is difficult for me to find that small loophole where I'll have them stumped. It is not possible. But yeah, the objective here is for you to learn the answers and not for me to show you how they fumble when they don't know the answers. I'm sure you have a lot of experience. Another thing I'd like to quickly add before I move on with my experiences, your answers will dictate, most of the times, your answers will dictate the next question. So if you have given a very detailed answer, you feel very excited about it and you've given a very detailed answer, trust me, the interviewer is not going to ask you anything on that topic, on that machine learning algorithm totally. He or she knows that this fellow knows perfectly about it. So if you'll have to be a little bit of an actor also in that. You'll have to show a little less enthusiasm towards topics that you know perfectly well, and probably, fake a little bit of enthusiasm for things that you don't know. These are, again, this has to be coupled with the knowledge. You cannot simply fake your way through it. Your knowledge is 80-85%. That 5-10%, whatever is there, is what I meant this. Please do not, take this as the main study point of it. These are just the additional aspects. Thank you so much, Barney and Sharath. And yeah, coming back to the topic at hand. So today we are going to be discussing about, deployment. And my question will move to Sharath first. And Sharath, deployment, your choice and why? It's a two-part question. What did you choose, the methodology, and why? I would request you to focus predominantly on the why. How we have deployed it, I think we have a separate series on that. So the why aspect is what I would be looking at.
Yes, Nitin. If I have to be brief, probably I would say any of the cloud platforms which give me end-to-end feasibility to deploy is my first preference or first choice. But again, as Bernie has mentioned, the cost factor comes into the picture. And if your client is willing to take that burden, if they are inclined towards getting the results quicker, faster, and for that they compromise on a little bit of additional cost, then always prefer cloud platforms, because these are readily available solutions and you just have to be doing a click away. Cloud platforms are built to do all this. And there's very important aspect that you need to remember is the ML ops standards. Any deployment that we speak about, whether it is a machine learning, whether it is any other solution, it could be a very simple mobile application development or any software development. There are certain standards that we have to follow. And these standards are nothing but your ML ops standards. And this is another very, very important aspect that is picking up post-COVID era, like I said, where the focus on these post-deployment and post-model development aspects are focused heavily on. As I said, I would choose AWS for a simple fact that it is the most widely used cloud platform, and their services are very, 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 I should say, simple, easy, and versatile. You'll also have a lot of customization features. So there you go. That's the solution. But again, if the cost is a primary factor, then you'll always can fall back to any of the open source platforms. You'll have to have the web UIs, then you'll have to use the tools like Heroku or any other cloud-based platforms for deployment. There are many open source tools like TFX. We have Kubeflow, MLflow libraries, which can be used. Yes.
Okay, thank you, Sharath. I was just kind of a little distracted about your answer. You mentioned about anything can be, chosen. All the cloud platforms are equally good. So again, this is not related to deployment, but maybe Barney can answer this question. It's totally off the track. Why is it that in most of the JDs, the three cloud applications that are there, they expect people to know all the three when anything is good enough? I mean, could you, sorry, it's supposed to be about deployment, but quickly, if you can answer that.
Yeah, sure. So, India predominantly is service-based industry when it comes to IT, information technology. You have Infosys, TCS, Wipro, Accenture, Deloitte, PricewaterhouseCoopers, EY, and Capgemini, and HCL, and bunch of companies. And all of these companies cater to different customers from different industries and sectors and domains. They might cater to Novartis, they might cater to Google, they might cater to ICICI Bank, they might cater to HSBC Bank, they might cater to Tata Motors, they might cater to Volvo. It depends. And we cannot expect every customer to use the same cloud environment. A few of them might be more inclined towards AWS. A few of them might go with Microsoft. A few of them might go with Google, right? And these are the major players. They have the might of money. They have the might of intellect. They have the might of data. So combination of these make them very competitive in the market. While it is oligopoly, wherein there are a lot of players who are competing, we predominantly see these three players, big players, competing extensively. This is one thing. And the second thing is we also need to bear in mind that if, say, Coca-Cola, for instance, says that I want my data to be placed on AWS, then the immediate thing that they would look at is PepsiCo also hosting their data on same servers on AWS? While AWS says, and every other cloud provider says that your data is secure. We would not have access to your data. We would not try to meddle with your data. But still, the big players have their own inhibitions. They might feel that, what if Amazon gets access to our data? What if Amazon tomorrow wants to enter into food and beverages industry, right? And what if we have PepsiCo also, which is hosting data on AWS? Would AWS then trade off our data with PepsiCo for some price, some insider trading? Is that a possibility? Maybe yes, maybe no. We really are not sure. So the clients might say that we want to place our data in different other cloud provider environments. So it becomes imperative for us to know all of these different cloud providers, right? That's my take, Nitin,
Okay,
with respect to
thank you. The last
different
bit
cloud.
was pretty interesting about competition and things like that. But yeah, while it is in theory, the very fact that in theory, if you see that, will Coca-Cola know if Pepsi is having their data in the same cloud platform as where they propose to go? In theory, it is not possible, but I think we are beyond theory now, I think. So we will leave it at that and just move on. All right. So, Barney, coming back to the question at hand, I mean, of course, I had taken a slight detour there. So, deployment. All right. So, what is your favorite? Because you've been instrumental in researching about a lot of deployment tools. We have been discussing in the last 8-9 months or so, new things that have been coming. So, with reference to the ease, etc., what do you feel?
Okay, there are two things once again, Nitin. Rather than I speak about my favorite, I would probably try to, pitch these two against one another. That is on-premise deployment versus cloud deployment. When it comes to cloud deployment, the good part is you need not do a lot of programming. You need not worry about too many integrations and all that. Cloud would take care of a lot of those things. Right? It's just on a click of a button, you would deploy a model. And you can deploy the model on a mobile application or a web application or a business application, and the end users can readily start using the model that you've built. However, if you do that, you would become, you probably will get latched on to that cloud environment. Tomorrow, if you want to switch from one cloud environment to another, it might be costly affair. Migration might be costly. You might need human resources to handle the new cloud onto which you would have migrated your deployment, your models. And if you get overly dependent on one of the commercial cloud environments, what if they increase the price of cloud usage? You will have no other option than to, go ahead and spend more money. So given all these risks, people are trying to have on-premise deployments also. Okay, and for security aspects and various other aspects, if people have already invested heavily on their own data centers, then on-premise deployment is what they prefer. And it also depends on, the maturity of the organization, how much they rely on the different continents which have the prowess over the cloud, environment. It depends on various other factors, right? So while we have cloud environments wherein you can deploy the model, it will make your life easy in terms of maintaining, in terms of deployment, in terms of reduction of time to deploy the model. For all that, cloud is more preferred. But if you are very wary about your data security, data privacy, if you feel that your security norms are far stronger than these other players, then you might want to save your data on your own environment. For example, Coca-Cola, right? Especially Hindustan Coca-Cola Beverages India Private Limited. They have the data on their own premise because they are very, very keen to ensure that they protect their data. They do not pass the data to the outside world for whatever reason. So for those kind of people, on-premise deployments make more sense. So it's again horses for courses. We need to understand the client requirement And then we should judiciously take a call on whether on-premise makes more sense or cloud deployment makes more sense. You need to look at human resources, the skills that they have, the knowledge levels that they have, what is the learning curve with respect to the different cloud environments, and versus if it is on-premise, you need to have a system administrator, network administrator, database administrator, and are you willing to spend that money? That's a call that we have to take
All right.
before deciding upon cloud versus on-prem deployment.
Thank you. Thank you so much, Bernie. So, Sharath, I was just recollecting your answer, and then given that you people are extremely experienced, you have unbeknownst to you, you sometimes drop certain words. So you used something called as MLOps. Now, a traditional data science student, while knows MLOps, the word, and maybe very, very rudimentary information. So could you probably spend maybe a minute and a half or 2 minutes explaining a little more about what MLOps is vis-a-vis the deployment?
Yeah, sure, Nathan. Yeah, thanks to bring that question. It becomes very imperative and very, very important for today's data scientists or students or participants who want to build their careers in data science. The point is, as I mentioned, pre-COVID era and post-COVID era. Prior to COVID, the data scientists used to follow a standard methodology which was called as CRISP DM. I mean, I'm pretty sure a lot of our participants are familiar with that terminology, CRISP DM. But this CRISP DM methodology has certain challenges, like what you do for ensuring that there is continuity of your model in the client's deployment, after deployment, in the client's infrastructure. Is this model going to continuously work as it is going to be be there for new data also? Because businesses tend to change, and when businesses change, when their vision change, or then when their priorities change, the data also gets queued. It also gets adjusted or changed based on these visions or whatever the parameters that we try to focus upon. Now, if data is slightly changing, then the new data that we get and the old model that we have already placed in the infrastructure may not gel well. That means the performance of the model would not be appropriate. It would not give us the desired results. Hence, we need to ensure that the maintenance and monitoring, this is one of the important aspects that has been brought into the standard methodology, that is your CRISP MLQ. So CRISP DM, you can say, has evolved and became CRISP MLQ. This one ensures that the post-deployment activities are also considered. So if you talk about any software, you need to ensure that the development itself has happened in such a way that it can be easily deployed at the end user, and there is continuity with respect to the model's training and usage or functionality, you can say. So to ensure this happens, there are certain standards that we follow. These standards are called as MLOps standards, machine learning operations, basically. And students who come from development background, probably they can very easily catch up the word. There is something called as DevOps, development and operations, right? So that is basically getting involved in machine learning world now. And this is a very, very important phrase that is catching up. We'll talk about more on these lines, Nathan, permitting a brief amount of time for this topic.
Yeah. So we've kind of time boxed this to exactly a 30-minute capsule. So we are just completed our 30-minute capsule. So audience, friends, and your friends, I see the numbers coming in are steady, which is a good thing. There is a slight increase in the number of people logging in every day to watch that, but that is pretty marginal. I mean, I'm sure you are well connected, you have friends, you have colleagues, etc. So I'm sure it should not be difficult for each one of you to pull in at least 3-4 people to come and watch this. And I'm sure once they attend these sessions, they'll be standing to benefit from it. So please do spread the word. That's all we are asking from you. And then we are here to give you all the support, whatever is there. All right. So yeah, on that note, thank you so much, friends. See you all tomorrow once again. Good night.
Thank you. Good night.
You're right.